Let me admit everyone first. Oh my god. Okay, maybe we can get started. So let me admit. Okay. So I guess today the plan is finish, chapter 1 and then introduce chapter 2. So it seems like, we're moving on to a different topic, but so I'll try to make it clear, why we're learning the stuff we're learning. So, so just to make sure everyone understands chapter 1, I'm gonna, for the maybe first 40% of the class, go over some questions just to test you all. So let's do something easy, like true, false. So 1. So I'm taking this from the chapter review, yeah. If f is 1-to-1, then f inverse of x is 1 over f of x. Is this true or false? So you could type in the chat or just say it out loud. No, it's actually false. So note that's sort of why we put the inverse on like the inside. So this, right, the inverse of like x plus 1, right? If f of x is this, the inverse is x minus 1, right? Which is clearly not like 1 over x plus 1. Agree? So there's two different inverses, yeah? So when we write this, it's like the, when we write this, it's like the function where you compose, you get x, right? Or if you like, it's the, if f takes x to y, the inverse takes y back to x. So it's different from like this, right? If I put the inverse on the outside, then this is just like 1 over f of x, right? Like 2 inverse is like a half, right? So that's sort of, the reason why we put the inverse on like between the f and the parentheses, because it's not like you're not inverting the function. It's like inverse in terms of composition. Everyone clear so far? Yes? No? Okay. So, just gotta clear some stuff up. Okay, so if 0 less than a less than b, so a and b are positive, then ln of a is less than ln of b. Yeah, this is true, right? I mean, one way to see this is the graph of ln, right? It's increasing, right? Um, Another way to see this is, you're asking e to the what power is a, and e to the what power is b, right? And if b is bigger than a, the power is going to be bigger. So, yeah, this is true. This is false. Yeah. So let's move on. If x bigger than 0, then ln of x to the 6 is 6 ln x. Is this true or false? Yeah, okay. I guess people are really struggling with this. So this is false. So there's a difference between x to the 6 and ln of x to the 6. Yeah? So here, right, I'm taking ln of x to the 6th power, right? This is ln x times ln x times ln x, Honestly, I could have just wrote that out, but 6 times, right? so these are two different things, right? This one is equal to 6 ln x, right? So if I have ln of something raised to the power, I could bring the power out. But not ln of something and then the whole thing raised to the power. It's two different things. Is everyone clear on this? Like, I'm not trying to be tricky, but just to make sure we don't make these mistakes in midterm or anything. So, okay, great. So similarly, let me x bigger than 0, a bigger than 1. And by the way, I put x bigger than 0 because you can't log a negative number, right? So ln of x, sorry, over ln of a is ln of x minus ln of a. So again, this is false. Is this true or false? Yeah, it's false. Yeah, it's the same thing as number 3, right? We have ln of x over a is this, right? But ln of x divided by ln of a, these are two different things, right? One, I'm dividing in like the argument. The other, I'm just dividing two different functions, right? So this is false. So really quickly, why do I need a bigger than 1? Just testing whether you all are. Yeah, no 0, right? Because ln of 1 is 0, right? You're asking e to the what power is 1. Well, e to the 0 is 1. So ln of 1 is 0. So you can't have you can't divide by 0. Okay. So okay, enough of true false. So let's move on. So now let me just say if f of x is, so this is a bit harder, yeah, or somewhat. It requires a guess, but I guess that's why they asked it. F inverse of 6. So this is a bit harder because if you try to solve for f inverse of x, if you tried to solve f inverse of x, you're going to have to do x equals 2y plus 4 to the y. It's kind of hard to isolate y, right? In fact, I mean, I don't know any operation that does it like really easily, right? You would have to, yeah, really hard, right? Because you have two different y variables, and one of them's on the exponent and one of them's on the bottom. So this is really difficult, right? Trying to find f inverse of x, because you would have to solve for y. So instead, let's not, the question doesn't ask, I guess that's why it doesn't ask for f inverse of x, right? It only asks for f inverse of a particular number. So in this case, right, you're remember the inverse, if f takes x to y, f inverse takes y to x, right? So you just have to find something that maps to 6, right? Because if f of something maps to 6, f inverse of 6 maps back to that something, right? So you're asking f of what is 6? And I'm sure you can all guess this. So what number do you plug in to get 6? Yeah, 1, right? 2 times 1. So I mean, this is like a guess, but I think it's pretty obvious. So yeah, so f inverse of 6 is 1, right? It's kind of like, you did this before, right? Like if I ask you what's cosine inverse of 1, the question you're asking is cosine of what is 1, right? Same exact thing here. F of what is 6? Everyone clear so far? Yes, no. Okay. Now let's express as single logarithm. So I never really went over examples of, the operations of log. So let's just do this. Right, so how do I combine this to natural log of something? Right now I have 3 different natural logs. I want like one single one. So using that law, right, how do I change adding 2 logarithms of the same base, right? Of course, but so something like this, right? So I'm going backwards. Right here, I started with ln of x over a, and I get ln of x minus ln of a. So now you get to work backwards. So subtracting is ln of dividing. Agree? So what's adding? Yeah. So I'm not going to skip steps, so this might seem slow, but let's, so let's do this first. So adding is the same as multiplying, right? Now, I can't immediately combine, the second term, right? I know subtracting is dividing, but that's only if I have like ln and ln. So in this case, it's the same thing, right? Like this is x squared minus 9 to ln of x squared minus 9. So you have 2 options, right? This is just this term times 2. So you know that this is just negative ln of x squared minus 9, right? And then you're done. But, if this wasn't, you have to move 2 to like the top, right? And another way to do this is say this is equal to. So remember, I can also do it another way by saying this, right? Using this rule, right? To convert, except I'm going backwards again. So a number times ln of whatever is you could raise that number to the power, right? So what I can do is say this is ln of x squared minus 9 minus ln of x squared minus 9 squared, where, the square is, of course, in the inside. And then I could apply division, right? So this is ln of x squared minus 9 divided by x squared minus 9 squared, which is just ln of 1 over x squared minus 9. Everyone clear? So why is this thing, if I could box it, the same as this? Well, same thing here, right? You can move this part right here. Let me just box this. This negative is just -1, right? So you can move it to become a power. So if you like, this is ln of x squared minus 9 to the -1, right? Where, as you all know, the -1 is on the inside. So this is 1 over x squared minus 9. Yeah? So however way you want to do it. Everyone clear on this? Okay. Great. So let me, last one. Yeah, now that I realize I never really went over logarithm examples. So what's ln of 1 over e cubed? So to answer the question, yeah, I mean, you don't have to bring the negative to the exponent. It's just, I was just showing why they're equal. Yeah. So like here, like I was saying, like this term right here and this term right here are like the same. But like, you know, I was just explaining why they were the same. Because a priori it looks different, right? But no, it's true for numbers too. So like what I did here, right? If you look here, I have 2 ln of x squared minus 9. I moved the 2 to the top, like right here, right? I made it ln of x squared minus 9 squared. I mean, a sign, the negative is just -1, right? It's still a number. Negative is just, you're just multiplying by -1. So I move -1 to the top, right? Okay. Yeah, so here, for people who said it, it's -3, right? Because this is ln of e to the -3, right? If I rewrite it, sorry, let me put parenthesis. And then you're asking e to the what power is e to the -3? Well, it's -3, right? So, one more. So again, the book, I think when they just write log without a base and without a number, like to tell you what base, it's implied it's log 10. Yeah. Just like how ln is log e. If they write log, just assume it's like log 10, log base 10. So what is this? Yeah, it's 1 over 64. Is 4 cubed 64? Yeah, it's 1 over 64. So here you see you can't really evaluate it, right? Because I mean, directly you can't really do that, because if you tried evaluating log of 1 over, because this becomes, I skipped a step, but this is 4 to the negative 3, right? I can move a number to the exponent, and then this is 10 of log to the 1 over 4 cubed. Because if you try evaluating this directly, you're asking 10 to the what power is 1 over, 1 over 65. I guess you can, right? So here, this is whatever power, this is x, where x is x squared. 10 to the x is 1 over 4 cubed. And then if you raise 10 to the x, you get 1 over 4 cubed, right? Because you have a 10 here. So, I mean, a faster way is just notice it's a law, right? So f of x is 10 to the x. You have that rule, right? The inverse is log of x, so log base 10. So I have f of f inverse of x is x. But if you write what this is 10 to the log x. So I'm applying this for x being 4 to the, this thing is like up right here. I'm applying it to 4 to the negative 3. Is everyone clear on this? So whatever this is, I don't know what this is, yeah. But by definition, it's just whatever power you raise, they get 1 over 4 cubed. Yeah, so this one's a bit harder because you can't really find what x is directly without like a calculator. Okay, so is everyone clear with chapter 1? I'm gonna move on to chapter 2. So, okay. So let's continue. So let me just sort of explain why we're learning the stuff we are in chapter 2. So if I gave you like the graph of like a line, right? Y equals x. What is the slope of this line? 1, yeah. And similarly, if I gave you like any line, right? Like any straight thing, like, I don't know, something like this, you would calculate this by, as you know, like you pick 2 points, you calculate the change in y, right, over change in x, right? That's called like the slope. So the question becomes, slope is sort of like how steep you are, right? If you want to think of it that way. So like, this is slope 1 is this steep, this is steeper, so it's a bigger number, right? Like slope 100 is steeper than slope 1, so on and so forth, right? So, but now here comes the issue. What if someone asked you like, what is the slope at this point? Because there's still a notion of how steep it is, right? So what you're going to see is, this is hard. Like if you don't know math, if you don't know what topics Math 2A covers, right? Because things are curvy, right? When things get curvy, it's hard to find the slope because, you know how to find the slope of straight things. You just do change in y over change in x, but you can't do that for curvy stuff. So you see the goal here is to learn tools to help you find slopes of, I guess, curvy stuff. No, it's not technical. Don't. I never define curvy, but just think of it as not straight. Okay, I'm trying to make it like easy to easy to understand. So you have 2 choices, right? So the first choice is what we're gonna do is you pick a point here, a point close by, and then you consider the line through it, right? So note that the closer you choose your point, the the better it becomes, right? So if like the better the approximation, right? So the first idea is to approximate. So there's a notion of a tangent line. I'm not going to go over it. It's like basically follows the direction of where your thing is. So it only touches your point once. So you see, like, sort of like if unless you're using a microscope in like a neighborhood of this point, like it's pretty much the value of the function. So let me draw better. So like this. Yeah. So you see, like in this neighborhood, like, the value of the line is sort of like close to the value of the function. So one way to solve this is to approximate using points close by. And one of the applications is velocity, which I will get into later, right? So you basically take the average velocity over points close by, right? So there's average velocity. So think of average velocity as like the approximation. And then there's something called instantaneous, which is the actual velocity. Instantaneous. Yeah, so think of instantaneous velocity as like, the actual slope. And then average velocity is, the like the approximation. So the reason it's velocity is because think of y as like the y-axis as distance and the x-axis as time. Then if you I'm bad at science, but I'm pretty sure distance is rate times time. So if I do change in y, right? Change in y over change in x, what are the units? Well, y is distance. So this is distance over time, right? So you see that as like rate, or if you like another word is velocity. So that's why it's related to velocity. And that's what we're going to be doing like for like 2.1. So that's the first choice you have, and I guess the second choice is be smarter, use other stuff. The reason I say this is because we never learned it yet. So, but what you're gonna know is we're gonna use stuff like limits / derivatives. So by the end of the course, you should know how to find the slope of, this is the function y equals x squared, right? So you should know how to find the slope of x squared at like the point 2, right? Using stuff here. But, what we're going to do is we're going to go with the first one first. Is everyone clear so far? Yes, no. Okay. So, I think the best way to do this is it's going to be a lot of word problems. So bear with me. Deck of bridge. I'm taking this from the book, so I'm not good with making word problems. Suspended 275 feet above a river. If a pebble falls off the side of bridge, the height in feet of the pebble. Right, so you sort of see the function they're going to give you is like the distance, right? Because distance is y, and in this case it's like height, right? So it's a function of time, yeah? So as I said before, right? And then we're trying to find the rate above the water surface t seconds given by, oh, after t seconds. That made no sense. Given by y equals 275 minus 16t squared, yeah. So now it sort of matches the problem, right? Because at time 0, you were 275 feet above the river, right? And then as the pebble falls, the height becomes smaller and smaller, right? So you're subtracting off something. So the question is find average velocity. Velocity for pebble. For time period beginning t equals 4 and lasting, so I 0.1 second. So 2 is 0.05 seconds. I'm not sure if it should be plural, but 0.01 seconds. So really quickly, like I skipped the second question, but what do you think the second question is going to ask in terms of instantaneous velocity? Like what would they want the instantaneous velocity? Like at what time? So you see here, we're sort of approximating the instantaneous velocity at 4, right? So what you're going to see is for I, well, what's the average velocity? Change in y over change in x, right? So again, I give you 2 points. You give me, if you like, this is f of t. And then if I give you 2 points, you could find the slope, right? So same exact thing here. You have the point 4, f of 4, right? And then I guess in part I, 4.1, f of 4.1, right? So the average velocity, so I'm not going to calculate this. I trust we can all do algebra, but so, you know, f of 4 over 4.1 minus 4, right? Whatever this is. So, you know, I'm pretty sure, I think on the book it says this one, you can use a calculator, but you know, if you're not allowed a calculator, the numbers should be nicer. So don't worry about that. And then part 2, right? Same exact thing, right? 4. So this is a good approximation, right? It's 0.1 away from 4. But now you get closer, right? You take a point even closer to 4. So in this case, 4.05. This will give you an answer closer to the actual velocity, right? So same exact thing. F of 4.05. Right? And then similarly, the last one should be even closer, right? So for part I, you're doing 4 f of 4 and 4.01 f of 4.01. Sorry, no space. So f of 4.01 minus f of 4, whatever this is, right? So you see, to figure out the velocity, if you're like, if this is not a word problem and you're just trying to do something, you're just trying to find the actual velocity at, say, time equals 5, then maybe for you might choose points even closer, right? Like 5.0001 and then 5.00001. Yeah. Okay, does everyone understand average velocity? It's just slope. Like, it's just another word for slope. but in the context of distance word problems. So it's nothing new. Everyone clear on this? No. Okay, so I'm gonna do one more but I'm gonna ask all of you, and then I'm gonna go back and do like a sort of like a population growth thing because I think I skipped that. So the displacement. Oh, by the way, the population growth thing is also word problem. So you're gonna get a lot of word problems today. Of a particle moving back and forth along a straight line is given by equation sine of pi t plus 3, where t is measured in seconds. I mean, they give you the equation, right? No, most of the time, like 2a is easy. Like they give you the equation, and then you just find the slope. So really, if asked for average velocity, it should be like 3 points on the midterm, and you're just finding the slope. So, but in case people like don't know what displacement is, I think the best way, correct me if I'm wrong, I'm not a scientist, but like if I take one step forward, like if I take like one feet forward and then 1 feet back, the distance I traveled is 2 feet, but displacement is 0 because like it counts in the negative, it counts like the moving back. So I think that's the difference between like displacement and distance. But anyway, so again, find average velocity between, in the time interval 1 to 2. So you would do, if you like this, S of t. So S of 2 minus S of 1 over 1. So in this case, we can actually solve this. So, I mean, I hope we can. This is 2 sine of 2 pi plus 3 cosine of 2 pi minus 2 sine of pi minus, the minus distributes, minus 3 cosine of pi over 1. So sine of 2 pi is 0. Sine of pi is also 0. And let's see, what is this? So cosine of 2 pi is 1, right? Cosine of pi is negative 1. So this is 6. Agree? 3 plus 3. Everyone agree? So I'm just gonna do, so the rest asks for this, right? In this case, you can't really calculate it. You would need a calculator. So the book said you need a calculator, so don't worry about that. But again, for part 2, you would do S of 1.1 minus S of 1 over 1.1 minus 1. So quick question, what are we trying to find the instantaneous velocity of? Or what are we trying to approximate? The velocity at what time? Assuming you did up to, 1, right? You're taking points closer and closer to 1, right? So we're sort of approximating instantaneous velocity. I don't know how to spell this. Instantaneous velocity at time equals 1. Okay, let's do one last word problem. So this is on exponential growth. So remember an exponential function. I'm not sure if you have this on your homework actually, but it's a pretty common question. So it's of this form, right? Some number times b to the t. So I didn't use x because if it's exponential in exponential growth.
It's running in the shines on my screen. Oh, I thought you meant that.
Okay, so it's exponential growth, right? It's normally it's like a population growing over time, growing or decaying, right? Growing or decaying over time, right? So that's why I use t, because when we talk about growth, the x variable is time. So okay, let's do a word problem. The viral load for an HIV. I guess science majors will be interested in this. Is 52.0 RNA copies. Again, don't ask me like what like RNA is and stuff. I have no idea. Before treatment begins. Eight days later, viral load is half. So again, it's assuming things decay and grow exponentially. Yeah, half the initial amount. A, find viral load V of t after t days. And B, find viral load after 24 days. So if you figured out A, B is easy. Yeah, you just plug in, you just do V of 24. So C, after how many days will viral load be reduced to 2.0 RNA copies per. Okay, so it seems like we're decaying, yeah, since it's getting smaller and smaller. So whenever you see questions like these, you know, the information they give you, it's to find A and B, yeah, and because once you find A and B, you can solve A, B, C easily. So let's figure out, what A and B are. So let's use the first information. So before treatment begins, Y, think of Y as, RNA copies. So before treatment begins, we have 52 RNA copies. So before treatment begins, what is T? Like what time? How much time has passed if, treatment didn't begin yet? How much time has passed? 0. Great. So we have Y. So we have at time 0 is 52. So 52 equals A times B to the 0. Well, B to the 0 is 1, right? Any number to the 0th power is 1. So this is just A, right? So A is 52. So we found the first one. Now it says 8 days later. So when T is 8, viral load is half the initial amount. Well, the initial amount is 52. So after 8 days, I'm at 26, right? Wait, 26, yeah. 26 half of 52. After 8 days. So now you can solve for B, right? This is a half equals B to the 8. How do I solve for B? Most books would just ln, so so let's ln it. So ln of a half is ln b to the 8. Let me take it back. Whoa, I take it back. B is not an exponent. I misread this. Ignore that. just root it. So this is B is 1/2 to the 8th to the 1/8 power. Yeah. Sorry, I don't know why, but I read B as being an exponent. So this is B, whatever this is. Yeah. So I'm gonna continue. So my equation, I'll move back and forth. So y is 52 1/2 to the 1/8 t. Yeah. Everyone agree? That's my equation. So I'm plugging in B back to here. So yeah, this is V of t. So this is part A, right? After t days, we have this many RNA copies, right? So for part B, it's after 24 days. So V of 24 is 52 1/2. 1/8 times 24. So that's 52 1/2 cubed. So 52 times 1/8. What is that? 26 over 4, 13 over 2. Yeah. So this is 13 over 2 RNA copies per, I think it was milliliters. So part C, after how many days will viral load be reduced to 2.0 RNA copies per milliliters? So my answer, right? What am I trying to find? Are they giving me the Y value and I'm trying to solve for the T value? Or are they giving me the T value and I'm trying to solve for the Y value? So it's 2.0. Yeah, they give us Y, right? I mean, if you just think about what T is time, right? And they're asking after how many days. So that should tell you that you're trying to find T. So was it 2.0? Sorry. I'm really bad at memory. 2.0. So 2 equals 52 1/2 1/8 t. So the question is asking you to solve for t. So if you like, this is 1/26 equals 1/2 to the 1/8 t. Natural log both sides if you like. I mean, you don't have to natural log, right? You could do log base, whatever you want. I just prefer natural logging. So 1/2 to the 1/8 t. Right, so this becomes, instead of putting equal, let me put an arrow. So ln of 1/26 is 1/8 t ln of 1/2. So ln of 1/. So again, do not, just combine this, right? ln of 1/2. This is not, no, this is why I asked this earlier. This is not ln of, 1/26 minus ln of 1/2 equals 1/8 t. So t is whatever this number is. Yeah, you would need a calculator for this, but everyone clear? So for like growth questions, the information they give you is to find A and B, and then once you find A and B, all questions become easy. It's just either plug in T, or they give you Y, solve for T, or they give you T, solve for Y. So, everyone clear on this? Good, yes, no. Okay, so with that, so on Thursday, I'll get into, new stuff. So limits and stuff like that. So, yeah. this might be boring for some of you.